Hello and welcome to our MathTalino tutorial. In this video, we will talk about the limits of functions. The study of the limits of functions is very important, most especially in the study of calculus, because it is one of the prerequisite topics in understanding complex topics in the said subject. In this video, I will not present the technical definition of the limit of a function. Rather, I will show the simplified version of the definition. So, what is really meant by the limit of a function? The limit of the function f is the y value that the function approaches as we substitute x values that are closer and closer to x equals a, but not necessarily at x equals a. This means that upon substituting values of x that are closer and closer to x equals a, the y value that the given function tend to approach is what we call our limit. To better understand, let's recall some basic concepts. Given the function f of x is equal to 2x plus 5, say, evaluate the function at x equals 2. Pag sinabing evaluate at x equals 2, isa-substitute lang natin yung 2 sa lahat ng x's na makikita natin sa given function. So we have f of 2 is equal to 2 times 2 plus 5, which can be simplified to f of 2 equals 9, because 2 times 2 is 4, then plus 5 equals 9. The number 2 that we have substituted is our x value, while the 9 that we have computed is our y value. In the context of limit, we are not really concerned at computing the y value upon substituting x equals 2. Kundi, yung concern natin ay kung anong y value ba ang ina-approach ng ating function kapag sinubstitute natin yung x values na palapit ng palapit kay x equals 2. So, we may ask the following questions. What y value will the function approach as x values approach to 2? This question is similar to asking what is the limit of the function as we let x approach to 2. So, to illustrate limit of a function, let's have the following examples. Find the limit of f of x equals 2x plus 5 as x approaches to 2. We mathematically write this question as limit of 2x plus 5 as x approach 2. In order to determine the limit of the given function, we may use function tables. We create a function table and assign values for x that are closer and closer to 2 from its left. Just imagine the number line. From the left of 2, we have the values such as 1.8, 1.9, 1.95, 1.99, 1.999, and so on. Notice the sequence of these numbers. It must be arranged in a manner that they get closer and closer to 2, so that we can clearly observe later the y value that our function approaches. Also, we make a function table and assign values for x that are closer and closer to 2 from its right. So we have 2.2, 2.1, 2.05, 2.01, 2.001, and so on. Again, observe the order of writing these values. They must be arranged in a manner that they get closer and closer to 2. Now, we are going to compute the corresponding y values by substituting these x values to our given function. Say for example, if our x value is 1.8, we may substitute in our given function 2x plus 5, so that becomes 2 times 1.8 plus 5. Then you just simplify and put it on the table. You also do the same to the other values of x, so that we can complete the missing values in our table. So, for the first function table, we have, and for the second function table, In the first table, observe that the y values approach to 9. Notice that the x values start from 8.6, then it jumped to 8.8, 8.9, 8.98, and 8.998. Also, in the second table, the y values approach to 9. From 9.4, it jumped to 9.2, 9.1, 9.02, and 9.002. It implies that the limit is 9. So, we write limit of 2x plus 5 as x approaches 2 equals 9. Alright, we now have an idea on how to determine the limit. Let's have another example. Evaluate the limit of x squared minus 1 all over x minus 1 as x approaches 1. Notice that when we substitute x equals 1 to the given function, it will be equal to 0 over 0, which is an indeterminate form. However, as defined earlier, in getting the limit of a function, we are not concerned necessarily at x equals 1. Rather, we want to know what y value the function approaches as x gets closer and closer to 1. Now, going back with the given, we can actually simplify it so that it would not be difficult for us when we substitute x values later. We can factor the numerator into x plus 1 times x minus 1. And notice that we have a common factor in the numerator and the denominator. Canceling out the common factor gives us x plus 1, provided that x should not be equal to 1. So, the given limit can be simplified to limit of x plus 1 as x approaches 1. At this point, ikukompute na natin yung limit using function tables. Again, we have to prepare two tables. One for the values of x that are from the left of 1, and the other one is for the values of x that are from the right of 1. Computing the corresponding y values, in the first function table we have, and in the second function table, now, in the first function table, notice that the y values tend to approach 2. From 1.8, it jumped to 1.9, 1.95, 1.99 to 1.999. And in the second function table, the y values tend to approach 2. From 2.2, it jumped to 2.1, 2.05, 2.01 to 2.001. So, we conclude that the limit of x plus 1 as x approaches 1 is equal to 2. Or we say that the limit of x squared minus 1 all over x minus 1 as x approaches 1 is equal to 2. Alright, let's have the third and last example. Evaluate the limit of 1 all over x minus 4 as x approaches 4. Notice that when we substitute x equals 4 to the given function, it will be equal to 1 all over 0, which is an undefined expression, since we cannot divide by 0. However, that is not our concern in finding limit, since we only want to know what y value the function approaches as x gets closer and closer to 4. So, this time, iko-compute na natin yung limit using function tables. Again, we have to prepare two tables. One for the values of x that are from the left of 4, and the other one is for the values of x that are from the right of 4. Completing the y values in the first function table, we have, and in the second function table. Now, in the first function table, the y values do not approach to a certain value, it's just going smaller and smaller. In other words, the y value decreases without bound, or its limit is negative infinity. Also, in the second table, the y values do not approach to a certain value. It's just going larger and larger, or in other words, the y value increases without bound, or its limit is positive infinity. Notice that the two limits from the left and from the right of 4 are not equal. So, the limit actually does not exist. Or we say that the limit of 1 all over x minus 4 as x approaches 1 is equal to d and e, or it does not exist. These types of limits will be discussed thoroughly in our next tutorials. So, that's it for this video. I hope you have learned something. Until next time,